Hello everyone, welcome to John Mac Classroom. In this video, I'm going to discuss the example for limits. Kindly refers to the question. Here we have the function f is defined by the situation given the fx. So kindly refers to the piecewise function and focus on the modulus of 1 minus x, where we have the modulus of 1 minus x, which is defined by we have 1 minus x and we have the domain 1 minus x greater equals to 0. Next, we have the negative bracket 1 minus x. And the definition would be 1 minus x less than 0. So here we have the definition. So kindly simplify the situation where we have the modulus of 1 minus x, which is 1 minus x for the domain x is less than equals to 1. Next, we have negative bracket 1 minus x, and we have the domain x greater than 1. So that is the definition for modulus of 1 minus x. Next, I wish to express or illustrate the situation in a real number line. So here we have the situation. The focus is the value of 1. Kindly refers to the piecewise function for the left hand side x less than 1. So where we have the function x squared minus 1 over x minus 1. Next, when x equals to 1, we have the situation m squared minus 2. And for the third case, we have x greater than 1. So meaning that we are focusing on this part. So the modulus of 1 minus x would be the negative bracket 1 minus x over x minus 1 plus with the n. So here we have the situation for these questions. A. If limit for x which is approaching 1 for the function f exists, find the value n. So when the mention exists, meaning that we have limits when x approaching 1 from the left, and the function would be x squared minus 1 over x minus 1 equals, because they said the limit exists. So we have limits when x approaching 1 from the right. So kindly refers to the number line, and we have the function x minus 1 over x minus 1 plus with the n. So kindly continue the situation. So focus on the left hand side. If we substitute the value 1, and we will obtain the indeterminate form. So my suggestion would be factorize the situation. So we have limits when x approaching 1 from the left, and for the x squared minus 1, if we factorize the situation, and we will have x minus 1, x plus 1 over x minus 1. So if we simplify the situation, and we will have limits when x approaching 1 from the left, and we have x plus 1. Focus on the right hand side where we have blue in color. So we have limits when x approaching 1 from the right. So kindly refers to the situation. If we simplify, and we will have 1 plus with the n. So finally, if we substitute the situation, and we will have 1 plus n. So focus on the left hand side. So we will have 2, which is equals to 1 plus n. So finally, n is equals to 1 for this situation. B. If f is continuous, means that they fulfill the condition. Condition number 1, we have f1, which is equals to m squared minus 2. Second condition, we have the limit exists when x approaching 1 for the function fx. So previously, we already know the situation where we have the value is approaching 2. Condition number 3, since the question said f is continuous at x equals to 1, so meaning that we have limit when x approaching 1 for the function fx is equals to f1. So in here, we can see that 2, which is equals to m squared minus 2. So kindly simplify the situation. M squared minus 4 equals to 0. If we factorize the situation, and we will have m minus 2 multiplied with m plus 2. So finally, the value of m will be equals to 2, and m is equals to negative 2. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share, and subscribe.